Here are some homework problems from section 3.1. On this first problem, we're supposed to find the inverse function and also find f of f inverse of x and f inverse of f of x and show that both of those equal x. The first problem, f of x equals 3x minus 5. When we're finding the inverse of the function, we follow these four steps. First, we use y instead of f of x, so instead of saying f of x equals 3x minus 5, write y equals 3x minus 5. Next, change the x's for y's and the y's for x's. So instead of y equals 3x minus 5, it's now x equals 3y minus 5. Third, solve it for y. So to solve this for y, we need to add 5. So that gives me x plus 5 equals 3y. Then divide through by 3, and I'll get y equals x plus 5 over 3. And then that is my inverse function, so label it that way. Call it the inverse function, so replace the y with f inverse of x. So my answer is f inverse of x equals x plus 5, that quantity, over 3. Now to determine if f of f inverse of x and f inverse of f of x equals x, you need to composite them together. F of f inverse of x means take the inverse function that we just got and substitute that into the f function right up here. So put this whole x plus 5 over 3 in for x on the 3x minus 5. So it will be 3 times this x plus 5 over 3, which I have right here, and then finishing it off minus 5 right here, minus 5. So what will happen when you simplify this is this 3 will cancel out with this 3. It will just be 3 over 3. That leaves you with x plus 5 minus 5, and 5 minus 5 is 0, so you just end up with x. And then checking it the other way, f inverse of f of x means take the f of x function and substitute it into the inverse function for x. So replace this x right here on the inverse function with 3x minus 5. So that gives me 3x minus 5, replacing that for x, plus 5 over 3. 3x minus 5 plus 5 over 3. Minus 5 plus 5 is 0, so you just have 3x over 3. The 3's cancel out, so you just have x. Let's go on to problem 3. Same thing on this. This is a messier function here. F of x equals the cube root of the quantity 2x minus 5 all over 7. So finding the inverse function, first use y instead of f of x, so replace the f of x with y. Next, change the x's and y's, so instead of y equals, we have x equals. Instead of the x right here, we have a y. Now we need to solve this for y, which is the hard part. So first of all, to get rid of the 7 in the denominator, multiply by 7, and you'll get 7x equals the cube root of 2y minus 5. Now to get rid of the cube root, cube it. Like if it was square root, we would square both sides. And it's only if you get this, isolate the cube root by itself here, which we did. So cube both sides, so we get 7x cubed. I didn't cube the 7, but I'm just leaving it this way. You could take 7 and cube it, and whatever that is would be x, then that number times x cubed, but I just left it like this. Cubing this cube root cancels each other out, and you're just left with 2y minus 5. Now just add 5 and divide by 2. Add 5 and divide by 2 to get it solved for y, and that's what the inverse function is, so just label it that. Then determining if these composite together will give you x is pretty messy here. So doing f of f inverse of x means take this inverse function we just got, this quantity 7x cubed plus 5 over 2, and substituting that in for x on the original function right here. Okay, so I'll be replacing that x with 7x cubed plus 5 over 2. And I did that right here. Then what happens is the 2's cancel out, so you're left with this. Now the plus 5 and minus 5 cancel out, so you're left with this. The cube root and the cube cancel out, so you're left with 7x over 7, and the 7's cancel out, and you're left with x. Going the opposite way, f inverse of f of x means that you'll take the original function right here and substitute it in for x right there. So that would be 7 times this hunk of stuff. All that gets cubed plus 5 over 2. Well, with this, the 7's cancel off, first of all. This isn't, this 7 gets canceled out with that 7. So now you're left with this right here. The cube root and the cube cancel out, so you're just left with 2x minus 5 plus 5 over 2. Minus 5 plus 5 is 0, and 2x over 2, the 2's cancel out, so you're just left with x. Let's go down to an extra problem here. On this problem, it says find the inverse. Is an extra problem I added here. find the inverse of f of x equals 3 over 2x minus 5. First, use y instead of f of x to get y equals 3 over 2x minus 5. Change the x's and y's, so instead of being y equals, it's x equals. Instead of being 2x minus 5, it's 2y minus 5. Now we need to solve this right here for y. So what I did to eliminate the 2y minus 5 in the denominator, I multiplied both sides by 2y minus 5. That will eliminate it in the denominator, but it'll put me a 2y minus 5 over here with an x. So I get x times the 2y minus 5. You can think of it as cross multiplying if you like. X times 2y minus 5 equals 3. What this x is over is it's x over 1. So I could cross multiply and just get 3 on the right hand side, and on the left hand side x times 2y minus 5. Okay, now we're solving this for y, so I can divide by the x, and that gives me 2y minus 5 equals 3 over x. Now add the 5 and divide by 2, and you have x 3 over x plus the 5, all that stuff, over 2, and that would be my inverse function. Now you can clean this up. This is a complex fraction. So both of these things are over 2, so I can put a 2 down there with the x, and I can put the 5 over 2. So this is a little bit cleaner form of this one right here. In fact, you could even go further and write them with a common denominator, and all that would be is adding the x to the top and bottom of the 5 halves. So this is the same as 3 plus 5x over 2x. But I just left it like this right here. And then finally, since that is my inverse function, then you can write it with this notation right here, f inverse of x equals 3 over 2x plus 5 over 2. Here are those functions simplified down farther that I talked about just a second ago. I paused it and simplified them. One thing interesting to note is that on the inverse function, it has a vertical asymptote at 0, and on the original function, it has a horizontal asymptote at 0. The original function has a vertical asymptote at 5 halves, and this has a horizontal asymptote at 5 halves. So the horizontal and vertical asymptotes are flip-flopped on inverse functions. Also down here, 5 says, what is the inverse of? Drive 2 miles south, then make a left, and drive another 3 miles. Well, here's what the guy did. He drove 2 miles south, down, and then made a left. This would actually be a left from the driver's perspective, and then drove another 3 miles. So the inverse function should take you back to the starting. So what do? Well, you drive 3 miles that way. What is that way right there? That would be west. And then you'd have to make a right and drive another 2 miles north. Notice that we did the opposite things in the opposite order. Instead of making a left, we made a right. We drove 3 miles here at the end, and we drove 3 miles first right here. And here's 2 miles south, which was the first thing, and we did 2 miles north here. Okay, let's go on. And 7 says, if f of 2 equals 4, what does f inverse of 4 equal? Well, f of 2 means there's a point at 2, 4 on the graph of the original function. And since inverse functions have x's and y's changed, that means there must be a point at 4, 2, the flip-flop of that. Now, 4, 2 is written, and this is an inverse function here, has this point. So instead of being f of 4 equals 2, it's f inverse of 4 equals 2. So what does f inverse of 4 equal? 2. It's like here's a coordinate x, y. So since the y's and x's are switched, f inverse of 4 must equal 2. Like if this was f of 3 equals 5, then f inverse of 5 must equal 3. So they're just flip-flop like that. And here's an extra problem. What is f of f inverse of 3? Well, the answer is 3, because f of f inverse of x always equals x. So whatever is in here is going to be right there. All right, now we'll wrap up this this homework bit.